In this module, we shall study about producer's equilibrium. The producers are always faced with the problem of deciding about combination of inputs that should be used for producing a commodity. A given level of output can be produced by employing various combination of inputs. A rational producer will always choose optimum combination of inputs to produce that given level of output. The combination of inputs is optimum if the given quantity of output can be produced with minimum cost, or if the maximum quantity of output can be produced with a given cost of production. This decision of the producers is called as producer's equilibrium. After studying this module, you would be able to know about the properties of isoquant, know about ridgelines and economic region of production, know about isocost line, understand producer's equilibrium. We shall now study about the isoquant. An isoquant represents all possible combinations of labor and capital that can be employed to produce a given level of output. Along an isoquant, the ratio of inputs keep on changing. It is also known as producer's indifference curve or production indifference curve because the producer is indifferent between these combinations of factors. All combinations lying on the same isoquant produce the same level of output. Let us suppose a firm producing 20 units of a product using different combination of factors. It is shown below. In the following table, factor combination N, P, Q, R, S, T has been given, units of labor R has been given, units of capital L have been given, and total units of output has been given. The above table shows that 20 units of output can be produced by employing 2 units of labor and 22 units of capital or 4 units of labor and 14 units of capital or any other combination of labor and capital. The figure shows that all different combinations of factors such P, Q, R, S and T are capable of producing 20 units of output. I repeat, factors such P, Q, R, S and T are capable of producing 20 units of output. An isoquant is based on the following assumptions. First, employment of 2 factors labor L and capital K. Second, given state of technology. Third, continuous production function. Next, isoquant map. A number of isoquants depicting different levels of output are known as Isoquant map. Figure shows an isoquant map where isoquant IQ1 depicts the lowest level of output of 20 units, while isoquants IQ2 and IQ3 depict higher level of output of 30 units and 40 units respectively. Higher isoquant represents higher level of output than the lower one. Let us now understand the properties of isoquants. The following are the main properties of isoquants. First, isoquants are downward sloping from left to right. Isoquant have a negative slope because if a firm wants to employ more units of one factor, then it has to reduce the units of other factor to produce the same level of output. It is assumed that marginal product of the factors is positive, that is, increase in the quantity of factor leads to positive increase in the output. Thus, if the amount of one factor increases, the amount of other factor has to be decreased to produce the same level of output. There are certain inconsistencies follow if the isoquants do not have a negative slope. If the isoquant are upward sloping, this means that the same quantity of output can be produced by employing less units of both capital and labor. That is, marginal product of at least one factor is negative. If the isoquant is parallel to y-axis, this means that the same quantity of output can be produced with the same quantity of labor and any quantity of capital. That is, marginal product of capital is negative. Thus, isoquant shown in figure 1.4 is not possible. If the isoquant is parallel to x-axis as shown in figure 1.5, this means that same quantity of output can be produced with the same quantity of capital and any quantity of labor. That is, marginal product of labor is negative. Thus, isoquant shown in figure is not possible. Second, isoquants are convex to the origin. This feature of isoquants is based upon the principle of diminishing marginal rate of technical substitution. The slope of an isoquant is known as marginal rate of technical substitution. It is defined as the quantity of capital K that a firm is willing to sacrifice for an additional quantity of labor L to keep the same level of output. MRTS is equal to delta K upon delta L. The MRTS goes on declining as we move down on the isoquant, showing that the quantity of capital that is needed to be sacrificed by employing more units of labor declines so as to maintain the same level of output. Along downward sloping isoquant, marginal productivity of labor decreases with the increase in units of labor, and simultaneously marginal productivities of capital increase with the reduction in the units of capital. Thus, lesser amount of capital is required to keep the output constant. If the isoquants are concave to the origin, this means that MRTS is increasing. This shows that firm is willing to sacrifice more and more units of capital for an additional unit of labor. This is against the principle of diminishing marginal rate of technical substitution. Third, two isoquants never intersect or touch each other. We prove this property by contradiction. In figure, two isoquants IQ1 and IQ2 intersect each other at point E. Point E shows that same combination of capital and labor can produce two different levels of output. However, it is not possible that one combination of factor can produce two different levels of output. This is illogical and absurd. Thus, isoquants never intersect each other. Higher isoquant represents a higher level of output. The figure shows that combination F of factors OL2 and OK2 on isoquant IQ2 represents higher quantity of output than factor combination E. OL1 plus OK1 on isoquant IQ1. OL2 plus OK2 produce 200 units of output, while OL1 plus OK1 produce 100 units of output. Therefore, isoquant IQ2 shows greater level of output. Fifth, exceptions to the normal shape of an isoquant. A. Linear isoquant. When the two factors are perfect substitutes for each other, then isoquants are straight lines with negative slope. Marginal rate of technical substitution between two perfect substitutes remains constant. That is, for every addition in one factor, equal amount of other factor is sacrificed. B. L-shaped isoquants. Isoquants are L-shaped or right-angled in case two factors are perfect complements. Two factors, say labor and capital, are perfect complements when they are jointly used in a fixed proportion for producing a good. A producer can increase the output by increasing the amount of both factors proportionately. There will be no change in the level of output if we change the quantity of one factor without changing the quantity of other factor. Figure shows that if labor units are increased from L1 to L2 without increasing the units of capital as shown by point R, then level of output will remain the same. The additional labor is redundant. Thus, both factors must be increased in the same proportion, say from point P to Q, to increase the level of output. Moving further, let us now learn about isoquants and economic region of production. In figure, isoquants are oval shaped. The oval shape of isoquant means that beyond a point, if firm increases the units of a factor, then it will have to increase the units of the other factor to produce the same output level. Over the convex part of the isoquant, if firm increases the units of a factor, then it will have to sacrifice some units of the other factor to maintain the same level of output. As shown in figure, A1, B1 part of the isoquant IQ1 has a negative slope. At point A1, marginal productivity of capital is 0. This means that output cannot expand if firm increases the quantity of capital keeping the quantity of labor constant. The addition of capital is redundant. The capital rich line is formed by joining the points A1, A2, A3 and A4. At these points, marginal product of capital is 0, that is MPK is equal to 0. Similarly, the labor rich line is formed by joining the points B1, B2, B3 and B4, where marginal productivity of labor is 0, that is MPL is equal to 0. These points are obtained by drawing a tangent to the isoquant parallel to x-axis. Thus, ridge lines are the locus of points of isoquants on which marginal products of factor is 0. The marginal product of capital is 0 at upper ridge line OA and marginal product of labor is 0 at lower ridge line OB. The region inside the two ridge lines formed economic region or technically efficient region of production. Outside the ridge lines, production methods are technically inefficient. Moving on to isocost line. An isocost line shows various combination of the two factors, that is capital and labor, that a firm can employ with a given amount of money for a given prices of the factors. Suppose a firm has rupees 400 to spend on two factors, say labor L and capital K. The price of labor is rupees 20 per unit and that of capital is rupees 40 per unit. This is explained in figure 1.13. If a firm decides to spend the entire amount of money to buy labor units, it can purchase only 20 units of labor and no units of capital. The firm will be at point Q. On the other hand, if it spent entire amount to buy capital units, it can purchase 10 units of capital and no units of labor. In this case, the firm will be at point P. If we join point P and Q, we get all the possible combinations of labor and capital which can be buy with rupees 400. This line is called an isocost line as total amount of money spent remains constant whichever combination of factors lying on the line is purchased. The slope of isocost line is equal to the price ratio of the two factors. Slope of isocost line is equal to PL upon PK. Next, shifts in the isocost line. Isocost line depends upon total cost or total money outlay and the prices of the factors of production. If the amount of money that firm spends on the factors increases or prices of both the factors decreases in the same proportion or vice versa, then isocost line shift parallel outwards. The reason is that firm can purchase more quantities of both the factors with the increase in amount of money or proportionate decrease in the prices of the two factors. In the present example, suppose firm increases the money outlay from rupees 400 to rupees 800, keeping the prices of the factors constant. Now, it can purchase 40 units of labor and 20 units of capital or any combination lying on the new isocost line. The new isocost line RS is shown in figure 1.14. There will be a parallel shift because the slope of new isocost line remains constant. Let us now understand the producer's equilibrium. The basic objective of rational producer is to maximize his profits and produces a given quantity of output with that combination of factors that is optimum. The optimum combination of resources is that, first, which minimize the cost of production for producing a given level of output. Second, which produce maximum level of output for a given cost of production. Thus, there are two cases of producer's equilibrium. First, minimization of cost subject to an output constraint. Second, maximization of output subject to a cost constraint. Case first, minimization of cost subject to an output constraint. If the level of output is given and producer aims to minimize the total cost of production, then he will be faced with a single isoquant IQ showing output constraint, B, a series of isocost lines. Higher isocost line represents higher money outlay. All isocost lines are parallel to one another because slope of all isocost line is same as the factor prices remains constant. The producer will be at equilibrium where the given isoquant is tangent to the lowest possible isocost line. In figure, producer equilibrium is at point E where isoquant IQ touch the isocost line RS. Therefore, he will employ OL units of labor and OK units of capital to minimize the total cost. Point above E is not desirable as it implies higher total cost. Point below E is not feasible though desirable as given output cannot be produced with these combinations. Thus, point E is the least cost combination point. At the point of equilibrium E, slope of isoquant and slope of isocost line is equal. Thus, the conditions of producer's equilibriums are, first, slope of isoquant is equal to slope of isocost line. MRTS LK is equal to PL upon PK. MPL upon MPK is equal to PL upon PK. MPL upon PL is equal to MPK upon PK. Second, isoquants must be convex to the, convex to the origin. Case second, maximization of output subject to a cost constraint. If the cost of production is given and producer aims to maximize his output, then he will be faced with, first, an isocost line PQ showing cost constraint. Second, a series of isoquants. Higher isoquant shows higher level of output. The producer equilibrium will be at the point where the given isocost line is tangent to the highest possible isoquant. In figure, point E is the equilibrium point where isocost line PQ is tangent to the isoquant IQ2. Therefore, he will employ OL units of labor and OK units of capital to maximize his output given the cost of production. Any point on higher isoquant IQ3 are desirable but not attainable subject to the cost constraint. Any point on lower isoquant give lesser output. Thus, point E is the equilibrium point. At the point of tangency, slope of isoquant and slope of isocost line is equal. Thus, the conditions of producer's equilibrium are, slope of isoquant is equal to slope of isocost line. MRTS LK is equal to PL upon PK. MPL upon MPK is equal to PL upon PK. MPL upon PL is equal to MPK upon PK. Isoquants must be convex to the origin. Let us now recapitulate what we have learned so far. An isoquant represents all possible combinations of labor and capital that can be employed to produce a given level of output. A number of isoquants depicting different levels of output are known as Isoquant Map. Isoquants are downward sloping, convex to the origin and never intersect each other. When the two factors are perfect substitutes for each other, then isoquants are straight lines with negative slope. Isoquants are L-shaped or right-angled in case two factors are perfect complements. Ridge lines are the locus of points of isoquants on which marginal product of factor is 0. An isocost line shows various combinations of the two factors, capital and labor, that a firm can employ with a given amount of money for a given prices of the factors. The producer is in equilibrium where the isocost line is tangent to an isoquant. The conditions of producer's equilibrium are MRTS LK is equal to PL upon PK, and isoquants must be convex to the origin. Thank you.